everyone. I hope you're doing well. I'm super grateful to be here, and also super nervous because this is going to be some kind of a live demo. So we're going to see how that goes, all right? So, today I'm going to talk about command line interfaces in particular. I love those, especially recently, and also a little bit back in time as well. I'll go through that. But before that, a little bit about me. So I'm based in Sunnyvale in California, in the Bay Area. I am a data scientist at Intuit, where I work for a decision science team. I'm also an editor at PyOpenSci, which is a nonprofit for broadening the acceptance of scientific Python packages. I love role-playing games, especially in my PS5 and my Steam Deck. I also think driving is very therapeutic as long as it's an analog car and not just an appliance with 4 wheels. So this is me driving on a track. I do that often. It's in Laguna Seca, if somebody's interested there. So yeah, so with that, let's go over to our agenda for here, right? So we'll go over why CLIs, right? What's the motivation behind it, and a little bit of my backstory of where do I come from here. I'll talk about argparse, which is the baseline functionality that we'll cover, and we'll also cover one sample use case there, and we'll cover those use cases both with typer, rich, and textual, okay? And we're also going to look at some production patterns, right? And we'll also do some live demo. So I loved Scott Irwin's talk, but he was spot on yesterday. Giving a talk is hard enough. So we'll see. So my first CLI experience was actually in year 2013. I was an undergrad student, and I had my Windows machine. And somebody told me, hey, you should install Ubuntu or Linux, right? So I went ahead and done that. It was like a dual boot because I didn't want to lose my access to my gaming machine, right? So this was my first Python project, and I was learning Git as a CLI. Everything cool. Anybody remember this color scheme, right? It was in Ubuntu. So I did git status, so everything is great. And by mistake, I did not write git commit -m, okay? So I just did a git commit, and suddenly it took me to here, okay? And I didn't know what was going on here, right? So I pressed some keys. This was basically the full editor. I pressed some keys, and no save button, no exit. I'm like, what is this? There is not even something written how to save this, right? So after struggling for about half an hour, actually, and I didn't want to ask anybody because everybody thought I'm the genius. So I finally wrote the message. I did not know what I typed, right? So I typed in my message there, and now the question remains, how do I exit, right? So how do I save and exit? So Control S, nothing happened. Control C, I went back to where I was. So and escape just beeped at me. I don't know what to be done. So after spending some time, I realized, okay, this is how it is, right? And this is not really a dig at VI or Vim. They're great tools, but it's one of those things where I think that great CLIs make things approachable to not just the pro users, but also the beginner users, so to speak. So this was really a humbling experience for me, by the way. So why do great CLIs matter? Well, they are fast. Well, they should be, right? Because CLIs don't have much overhead, no browser, no GUI overhead. They're composable, meaning that you can pipe output, chain tools, you can automate it, right? It's scriptable, meaning you can run in CI, cron jobs, SSH sessions, servers, etc. It's also universal, so which means it works everywhere. It can be made platform agnostic, so it can work in Windows, Linux, and Mac. And now these days, it's agent ready because an AI agent knows many CLI tools, so it's kind of like a bread and butter for them, right? So they are our newest users. So a good CLI is an API for humans, always was, and increasingly now for machines as well. So Let's go over to a running example. So I'm building a tool to monitor ML model explainability. I feel explainability is such a key feature or a key pillar of machine learning models. So the idea is to capture explanations as the model runs in production, understand which features drive the prediction, and then compare the explanations across different model versions or time windows. All right. Now the thing is that you don't need to have an ML background to understand this. It's just, you can just think of it as something like a black box here. So, and we're going to have 3 commands here. So one is log, which is log explanation values for a batch of predictions. So you need, let's say, a trained model for that. Then you save that to a disk, all right? Then you generate a report. And then there is some live monitoring that's going to be happening, okay? So log data, analyze the data, and watch the data live, right? So again, the domain does not matter here. So, but what do we really want from our CLI? Well, it has to be distributable in a virtual environment and also globally, because you want to make sure that you package your CLI not only for the developers or the Python developers, but also someone who does not have or does not know Python, basically, right? It should also support nested commands, subcommands, something that you nest within a bigger command, basically. And then it should also have type-safe inputs, ideally, right? So bad arguments are rejected with helpful errors at the top level. It does not go inside, right? Then there should be some kind of a config hierarchy. Now, what do I mean by that? I mean that if you say some kind of a flag, all right, that flag should take the first priority. Then if you have an environment variable, that should take the next priority. And then lastly, the defaults that are set in the CLI should take the last priority, right? So, and then some kind of a progress feedback. You want to know if it's a long-running job, just staring at a blank screen, like I did with the VI example, does not make much sense. So you need to have some kind of a feedback that's coming in. It has to be fast, okay? And it has to have good defaults, because that gives some lazy users a chance, right? Now, before we go into all of that, the first thing that we need to do is we need to make this into a command, which means we need to make this into an executable, right? So the best way to do that is in your PyProject.toml, you basically have an entry point to your app. So it could look something like this. So SHAP monitor is the name of the library, and then you have .cli on app, right? This could be a main, a dunder main, so it could be anything, right? So the pip install puts the SHAP monitor on the path, right? So that's pretty important. So now let's look at the argparse method, right? And how we do about it. So let's take an example of the log command, right? Remember, the log command was just generating some explanations and saving into disk. You don't need to know and go into the code that much, but all you need to know that there is a lot of boilerplate code that is involved here, right? You define the parser, you add arguments, you add some help, and then you parse those arguments. And of course, for subcommands, you'll have more stuff going on there. But the key thing is that you have to do these manual checks for if the path exists, right? If the model path exists, or some validation between some kind of a floating value, right? Whether they exist between some kind of a, let's say, range or not, right? So, OK, having said that, let's go over to the demo a little bit. OK. So I'm here, right? So let's do help. So this is using the argparse style, right? So you have these positional arguments, which is it has log, it has report, and that's great. So it comes with a default help command, right? So now let's do log help, and then it will give us the attributes or the flags that we can have, right? So now let's log something here. So I'm going to say, so you can see what all it takes. It takes some data, and it takes the model, right? So we're going to say the data is log. I have a demo folder, which is batch current.csv. And I have a model, which is in demo model.pickle, right? So it's going to save something to the disk. OK, so that's great. And then let's look at the summary for it. So I'm going to do shap monitor, report, summary. I can add more arguments, but this also works, or at least it should work. And you have something like this. So this is doable, and this is great. So now let's look at something else. So here, if I go, so let's look at the pain points. I mean, we know that, right? I mean, during the input, there is a lot of verbose argument definitions that you have to use. There is a lot of manual validation that you have to do. There is no config hierarchy that we talked about. And the text-only output basically means that it's not very, you don't get excited to use this tool, okay, in simple language. So now we have these two packages, which is typer and rich. And these two packages are not competing with each other. They are actually complementary to each other. So I think of it as a typer is for the input that you write for the developer, basically, and rich is for the output or for the user. So how do we do this, right? So the same log command, let's just look at that, right? Instead of adding all of those arguments, what happens is that typer in this case is declarative. What do I mean by declarative? It basically means that you focus on the desired outcome, letting the system manage the implementation details. So what you do here is that you using the CLI arguments or the type hints become the CLI arguments in this case. So we have data, model, data directory, sample rate. So in the case of data, you can see that it's a typer.argument, which means that it is a required argument. There are some things there, like exist and readable, which are very important. So the exist means that there is an auto-validation that checks if the path even exists in the first place. Readable, again, basically means that, again, auto-validation if the file or directory is even readable, like to the machine or to the user. And then you can see there is also a shorthand for the model where you can actually do that as a flag of model or just like -m, right? Again, the same things, exists and readable. And then finally, the best one is the data directory. So here you can see the config hierarchy coming into play. So you can actually override this flag as -- data directory, but there is also an environment variable. So you could have that exported, and set that to use it, right? So that's the second, I would say, priority that takes place. And the last one is just the path of shap logs. Okay, that comes into play, right? Even for the sample rate, we have some kind of a check, right, where that it has to be between 0 to 1. So with that, you also have subcommands and composition. So in this case, at the top, you can see we have the report app, right? So that is our main, like the main app, you can say. So the report, and within report, we're going to add two subcommands. We have summary and drift. You can just add that as a decorator, and then you just mount it with the app.addTyper on the report app there, right? So you could have something like this, where you report summary, and then you also report drift. Okay, so the next one is that you need some kind of good defaults in this case. So in this case, you can see that many people don't put that the -- help, right? So they just don't do that. Well, you could just make sure that when people write shap monitor, the help menu automatically comes up. So these are some good defaults that you can use, and we'll go into those now. So let's look at this. So now we will go to the second one, which is basically here. So if I do shap monitor help, it will give me all of this. So all of these text comes from rich, basically, which gives this beautiful UI for me to work with. It has a lot of things like already there. For example, you can install some completion as well, like for your ZSH RC file, and it will just autocomplete. So that's great. And then you also have these commands, right? But it's just more readable. So if I do something like shap monitor, this will do the same thing, because we added the fact that when there is no help, you actually display the screen. So that's how it looks like there. So if you go back, so now we're going to talk about Rich, which basically makes our life better in a terminal. It has progress bars, tables, panels, style text, and tracebacks for good error messages that you want, right? So the first one is the status indicator. You don't need to look like too much in the code, but basically what it does is that it gives us these functions for giving you the status of what is going on behind the scenes. So let's say a progress bar or like a spinner column where something you do not know for indeterministic work, right? So all you do is the code is very simple that you just add with progress, and then you add that task and you do that task, right? So if you go there, so it's gonna be so I'm gonna just log help. Right? So you can see there are many things that we see, right? So it gives me the shorthand notations, it gives me like everything and some of the constraints that I added there, right? So I'm going to do sharp monitor, and then you can see it auto-completes for me. So I'm going to do log, and I'm going to do demo batch. Oh, right. It's very hard to see. Sorry about that. Thank you. And then model. And then it is basically going to log. The same thing that we saw before, but it's going to do that, right? Another thing that we can do, now we can go over some of the other stuff, is that let's do the report, right? Report, if I do report and help, it has two commands. We can see that. And we can do report, summary. What does summary do? Right, show the summary statistics for sharp values in a time period. And by the way, all of these text that you see, it's actually coming from the doc strings. So you don't have to do some extra work there. So now what we're going to do is that we are going to do, again, I can use the shorthand notation. I'm going to take this as this, and I'm going to look at the last 7 days of data. All right? So, or maybe, just 2 hours till now. Okay, so this syntax is similar to git diff, like if you've used that, right? So, and you can see that I can actually make it work like so that visually, it's so appealing to me that I can see something like this. I immediately know that what is going on here. So for example, this is sorted by the mean sharp values, all right, like on the second column. And what I can do, and I can see that how much each feature is different or is contributing to my prediction. So that's great, right? Another thing that I can do, now we have a second subcommand, which is, let's see, report drift, right? Drift, yeah. If I look at the help, it's basically compare the sharp value drift between 2 time periods. So let's say you had a model running yesterday versus a model running today. How does those predictions differ, right? So how do you do that? Well, what we can do is we can do again, demo sharp logs, right? And then I can give my reference time period as maybe last 14 days to last 7 days, all right? And then the current time period is maybe last 2 hours to now. All right, so you can see something that is, again, very appealing to the eye because you know that what's going on. So PSI is, so you can think of it as a distribution shift. So it's a population stability index. And what you can see that the debt ratio feature has gone off wire between let's say, that time period and this time period. So something changed. Maybe the model just got off track, or maybe the data itself that was coming in that changed. But you can see that it is something that can be alerted, and you can just visualize this that something else is going wrong there. All right. So with that, let's go back here, and I'm going to skip some of these slides. Not too much, but here exactly what's going on is that the code is very simple. You have those visual weights that you saw, right, which is those bars, those blue bars that you saw. What is going on is just on this line right here where you have the bar LEN, where you're actually calculating like how much has, or I would say the length of that bar, right? And then you just create that bar for every row or every feature. So very straightforward, nothing crazy going on there. And even here, what you really do, like for those warnings, alerts, all of the statuses color-coded, what you're basically doing is you are just creating some Boolean variables for alerts, warnings, and stable. And then you are just adding those as a headline there. Okay, so again, nothing fancy. You're just checking which warning it is, whether it's a warning, whether it's an alert, or if it's stable, and you're just color coding it. So now we're going to talk about textual, and this is where things get a little bit tricky, where you have something interactive. All right. So when static output is not really something that you can work with, or you need something more, you need some kind of an interactivity, right? So examples would be live monitoring, expiration, or some keyboard-driven workflows as well, right? So now textual allows us to actually do that. So let's look at that, right? So here again, okay. So let's say this is our watch command, basically. Watch, I'm going to see what is going on here. And OK, shaft monitor. I'm going to do watch demo shaft logs. So here I have kind of a dashboard, like an interactive dashboard here. Okay, so all of these are features. It's in a tabular format. It's actually auto refreshing, like every 5 seconds, and it's a very simple one. There's nothing fancy. I mean, nothing is going to happen here, but the key idea is that you can go and create something more from here, right? So here, for example, I can filter by age, for example. Okay, and these numbers are actually changing by, you can see these are changing by every 5 seconds. You can bring up the command palette to actually see what is there, and you can just you can actually go into a rabbit hole with this. So you can create much more effective TUIs with this. All right. So with that, let's go back. But how are we designing it? So the basic structure is you have something called app, like for the textual, and you just create this class in which the CSS just controls the sizing as it normally does. You actually define everything. And in the compose, you define what are the things that you need. So these are all coming from the textual widgets. So the widgets provide a lot of these boilerplates. So you have the header, you have the input. The input is where I was actually filtering out things. You have the table that you saw there, and you have something at the bottom as well. So you can actually make this pretty complicated as well. All right. So the live data with auto refresh was happening here. So if you look at the mount, right? So what textual gives you are the lifecycle hooks. Okay. So the on mount runs exactly once. Okay, when the app starts, and this is where I wire up the table columns and load the initial data. All right. And then at the set interval on that line, you call it, and that's it. So every 5 seconds, textual loads the data again on the main event loop, and then you go ahead with that, right? So it also gives you some key bindings, right? So like Q, R for refresh, Q to quit, and all of that. And you can define those as well. So you define how the experience wants to be, right? You can also filter by typing and all of that. So now let's look at some of the production patterns and I think this is really important because it really makes your CLI stand out from just a toy tool versus something that can be used in production and used by many, many users. The first one is, I would say, composability. So a great CLI always has these mechanisms, especially to pipe out JSON output, right? And that is very good for like agents these days. So you can actually have an agent skill that tells the agent, OK, don't use the CLI in a normal way, but always use some kind of a JSON output, right? So in this case, for example, you can see that I was just looking at one feature, the top feature, and I could pipe it with JSON and JQ, and then it gives me just this. So this is very useful for an agent, for example. All right. Now, thank God I don't need to go into this too much, because there was a great talk today by Jacob. But the thing is that this is really important, I mean, especially for a CLI. Because when you use a CLI, you don't use it like a normal server or a service or something like that. When you import once and that's it, everything is cached, things like that. No, you really have to make sure that imports are quick. All right. So here in this case, this is a typical an init file on the main level, and then this is very normal to do, right? So you want to import SHAP monitor from an inside module. So what you're going to do is you're going to import it here and then have it there as all. But this actually increases your latency a lot. Okay, when you actually run even something like SHAP monitor help, this will get run, right? And you don't want that. So, and you want the help commands to be really, really fast, right? So there are many strategies, of course, and we saw in the talk as well. But what I personally do is I use some kind of a lazy loader library for now, just to make by before we wait for Python 3.15, where we have that thing. I also sometimes use local imports, even though they are not pretty, to be honest. I don't really like that, but it gets the job done in some way. Okay. Now, one more thing that you could do is that PEP 562 actually allowed you to define a module level getAttrs dunder method, okay, that intercepts the attribute access on the module level itself. So you could do something like this. So instead of that init method, what you do is you make sure that you import during the actual call of the SHAP monitor. So when you do import SHAP monitor, it only loads the module shell, right? But when you load something like from SHAP monitor, import that class, then it triggers what is actually needs to be. So you want to make sure that you do something at least like this to make sure that your help functions and your other CLI commands are quick, right? The next thing I would say is about distribution. So distribution is very important, because if your user is a CLI user, they might just install it inside a virtual environment. That's great, but they really might not, because as I said, they could be like a non-Python user as well. So the best way to do it, I feel, is using pipx, because it gives you a great isolated virtual environment to work at a global level. So you could just do it, and with no extra code, by the way. So when we actually created that executable command, that was it. It will make sure that you can do something like this. I just added the CLI as an optional dependency, so if users don't want to use it, that's fine. But I mean, you could just do it as a total dependency as well, right? You can also upgrade to Brew if you really want to, but they have a strict process of getting tools into their ecosystem. So make sure that you have enough users to justify that. But I think for most use cases, pipx is great. The config hierarchy, as I talked about, is really, really good, and it gives a lot of, I would say, inflexibility to the user. Okay, not only to the user, but also in systems. If let's say that they're using your CLI in different systems, then you could actually do that. Again, the same thing applies there, right? So all of these three statements work in priority order. So you have the first one where you give, then you have the environment variable, and then you have something that uses just the default, right? Now, when to reach for what? So if you just have a script, just use argparse. That's just enough, okay? If you have a big project and just needs argument parsing, then you just use typer. And then you keep on adding more. So you add rich for these structured outputs, for progress bars and things like that. And when you have some kind of a live data and TUI, then you use textual. Of course, we are standing on the shoulders of these great packages. There are also other packages as well. So those are also good. But I personally use these in my in my frameworks and in my work. That'll be all. So thank you so much. I think I we have some time left as well, so that's great. Yeah, thank you so much.
Yeah. Had a few questions come in. I'm probably going to send most of them on to chat, but I do have at least one or two I want to run by you real quick. Especially to highlight. Someone asked, do these libraries work with all consoles? Can you kind of talk about how that works?
Could you repeat that?
Basically, do these libraries work with all consoles across different platforms?
All consoles, right? I mean, I haven't really found anything because, look, these packages have a job to do, which is to work universally, right? So if they create one just for one console, it's not going to cut it. But for the major consoles, I think that works.
Yeah, I think that's one thing I love about the CSI stack is if you can run Python, you can probably make this work in it. Yeah. The other one I wanted to touch, how do you account for multiple tool chains? So pipx versus UVX tool. Do you have thoughts on kind of where to go there? I
mean, for CLI especially, I think you need a way to give users the access without a virtual environment. That could be pipx. I feel pipx is great, and it just works great. UVX also, it's a new and upcoming tool. If people have it, that's great. But I don't think you need some extra work to do that.
Fair. Cool. All right. Thank you so much.
Thank you.